Assalamualaikum. Welcome back to Cirque Labs Physics and Chemistry tutorial for high school students. In this episode, we focus on problems involving charging and discharging a capacitor connected in series to a resistor and a DC source. The circuit is commonly called an RC circuit. So just hang on, watch and learn. Question number 1. You connect a 10.0 mega ohm resistor in series with a 3.20 microfarad capacitor and a battery with EMF 9.00 volts. Before you close the switch at time equals 0, to complete the circuit, the capacitor is uncharged. Question letter A. Find the final capacitor charge. And question letter B. Find the initial current. Letter C. Find the time constant. Letter D. Find the fraction of the final charge on the capacitor at time equals 18.0 seconds. And question letter E. Find the fraction of the initial current present at time equals 18.0 seconds. Question number 2. You connect an initially uncharged 6.40 microfarad capacitor in series with a 5.00 mega ohm resistor and a battery with EMF 12.0 volts. After letting the capacitor charge for 51.0 seconds, you disconnect it from this circuit and connect it in series to an open switch in a 6.00 mega ohm resistor. Find the charge on the capacitor, letter A, when you disconnect it from the first circuit, and letter B, 70.0 seconds after you close the switch in the second circuit. As shown in the figure, the 3.20 microfarad capacitor is initially uncharged and is connected in series to a resistor of 10.0 mega ohm and a battery with an EMF of 9.00 volts. Initially, both current and charge are equal to 0. During the charging, the charge of the capacitor increases over time while the current decreases. And we are required to find letter A, the final charge, big Q sub F. This is the final charge on the capacitor. Letter B, the initial current denoted by I naught. Letter C, the time constant denoted by Greek letter tau, which is also equal to the product of R and C, or resistance and capacitance. Letter D, the fraction of the final charge on the capacitor at time 18.0 seconds. So we denote this here by small letter q over big Q. And letter E, the fraction of the initial current present at time equals 18.0 seconds. That is denoted by small letter I over I naught. So, to answer letter A, the formula for finding the final charge on the capacitor, big Q sub F, okay, we just multiply the given capacitance and the EMF of the battery. That is 3.20 microfarad times 9.00 volts. And we will get the value of the big QF equal to 2.88 times 10 to the negative 5 coulomb. For letter B, the initial current I0 is just using the Ohm's law formula. The EMF of the battery, epsilon, is divided by the resistance, capital R, that is 9.00 volts divided by 10.0 times 10 to the 6 ohms. Right? So we will get the value of the initial current I0 equal to 9.00 times 10 to the negative 7 amperes. For question letter C, the time constant RC, all right, is just 10.0 times 10 to the 6 ohm. This is the equivalent of 10 mega ohm already converted to ohm, and that is to be multiplied by the resistance or by the capacitance equal to 3.20 times 10 to the negative 6 farad. So doing our math, we will get the value of the time constant equal to 32.0 seconds. To find the fraction of the final charge of the capacitor at time equals 18.0 seconds, we apply the formula for small letter q over big Q equal to 1 minus the Euler's number raised to the power negative t over RC, or that is 1 minus Euler's number raised to negative 18.0 seconds over 32.0 seconds. So simplifying, that becomes 1 minus Euler's number raised to the negative 0.5625, or doing our math, we get the ratio small letter q over big Q equal to 0.430. And finally, for letter A, we also compute the fraction of the current small letter I over the initial current I0 at exactly time equals 18.0 seconds. All right, so the formula is small letter I over I0 is just equal to Euler's number raised to the power negative t over RC. Substituting, that's Euler's number negative 18.0 seconds over 32.0 seconds. And simplifying, we will get the Euler's number raised to the power negative 0.5625. So that our final answer for the fraction of the current small letter I over I0 equals 0.570. In question number 2, the initially uncharged 6.40 microfarad capacitor is connected in series to a 5.00 mega ohm resistor and a battery with an EMF 12.0 volts. After letting the capacitor charge for 51.0 seconds, it is disconnected from the first circuit and is connected to an open switch and a 6.00 mega ohm resistor. While discharging, the charge in the capacitor and the current both decrease over time. So our target variable or variables are letter A, the charge small letter q on the capacitor when you disconnect it from the first circuit. Take note, it is the amount of charge after 51.0 seconds of charging the capacitor. And the other target variable is the charge small q on the capacitor 70.0 seconds after you close the switch in the second circuit. So, in other words, during the discharging process, we want to find the charge that is left on the capacitor at time equals 70.0 seconds. And so our working formula for computing small q in letter A, all right, it is just equal to the product of the capacitance, capital C, and the EMF, the battery, epsilon, all right, to be multiplied by the quantity 1 minus Euler's number raised to the power negative t over RC. So, plugging in the data or quantities, small q equals 6.40 times 10 to the negative 6 farad times 12.0 volts. Alright, and this is multiplied by the quantity 1 minus Euler's number raised to the power negative 51.0 seconds over 5.00 mega ohm times 6.40 microfarad. So doing your math, we get small q equal to 7.68 times 10 to the negative 5 coulomb multiplied by quantity 1 minus Euler's number raised to the negative or to the power negative 1.60. And further simplification, small q now becomes 7.68 times 10 to the negative 5 coulomb times 0.798. And so, our final computed value for Q in question letter A is 6.13 times 10 to the negative 5 coulomb in 3 significant figures. For question letter B, the charge small letter q on the capacitor 70.0 seconds after you close the switch in the second circuit. So the working formula for finding this charge, small letter q, is just q or small q equals big Q naught multiplied by the Euler's number raised to the power negative t over RC. Alright? Take note, this is the required formula for finding the remaining charge small q on the capacitor while discharging for a given time small letter t. Right? So, plugging in the data, we get small letter q equals 6.13 times 10 to the negative 5 coulomb. Alright? The same charge that we got in question letter A earlier. So that's to be multiplied by Euler's number raised to the power negative 70.0 seconds over 6.00 mega ohm times 6.40 microfarad. So doing your math, we find the charge small letter q equal to 6.13 times 10 to the negative 5 coulomb times Euler's number raised to the power negative 1.82. Or, simplifying further, that is equal to 6.13 times 10 to the negative 5 coulomb times 0.162. So that finally, the computed value for the small q, okay, in question letter B, is 9.94 times 10 to the negative 6 coulomb. So that concludes our tutorial. Till the next episode, mabuhay, Masya Allah. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.